This is 10 at that mark.
Oh, yeah.
And so I'm going 5, which 5 thousandths means we actually moved out a quarter of a thousandth, which should take off a half, and we'll see what we got.
All right.
We put it in actual gear. Did I do that right? 5 thousandths.
So
Yeah,
like
5 thousandths should take off a half. It's, you know, because 1 thousandths on the diameter was supposed to be 10, and
yeah.
yep. And we always kind of look at things and see what does it look like when we're cutting.
See if the chips actually look like.
Yeah. Do they look like they're 2 or 3 thousandths or something scary? And they don't quite look scary. I would have hoped for a little better finish, but we'll see. And then what some people will do, and what you would do if we were grinding this, is we'd go through here and, well, we could do it either way. We probably would not. Watch out for touching, because you even touch the carriage, it can move things when we're doing littles. But when you're grinding, because your normal grinding, like on a center grinder, you would come through here, grind, and come back. You would go back and forth. But lathes are normally not quite that accurate on the carriage, and they tend to rock and drive a little bit different in one direction than the other.
Okay.
So if you have a way to do it, it's better if you can go through. Now again, if we back it off, now we've lost our extreme accurate positioning. So in this case, the thing that's a pain for us, that key, is going to be a blessing, because after we get it through, we'll stop it, we'll come to the key, and we'll carefully feed it back through the key so we're not dragging the tool. Because there's a keyway.
Yeah.
The things that are a distraction, we use them to our best still. When we're done, we'll look at the condition of our tool, condition of our bore, measure it with our dial gauge, see if this is going to work or if we need to do something else. And we won't get brave. I'm going to just take a 0.5 thousandths at a time. It's all we need to do. We're not trying to win a race here. We're trying to do very, very careful. And they will measure it carefully and check us when we're done. This is not going to be one of those, not like the the hitch in the at the drill press, you know. And the way that came about, that hitch on the drill press too. Now, once I knew what he was doing, I said it was, you know, okay, I go and drill him a hole. But I looked at what he had. What he had was an old, ugly piece of plate that he had found, and he was going to have a welder friend weld the plate onto the back of his hitch. The plate, which I drilled the hole in, of course, his welder friend also told him, get the best hitch ball that you can with the biggest stud size, which is why you need the 1.25 inch, okay? The instructions that came with the ball hitch, and this guy he just didn't know, you know, it wasn't his field. The machining's not his field, welding's not his field. He hadn't put a hitch on anything before. In the instructions, it said, be sure you have exactly 1.25 inch hole. It didn't say that you could be off at all. It didn't say anything else. It said it had to be exactly 1.25 inches. And what they meant, of course, was don't put it in 1 3/8 inch hole so it rattles around.
Yeah.
But that wasn't what they wrote on the instruction sheet that came with his ball hitch. So that's where the whole idea of thinking what he needed was more accurate than what it needed to be. And I did try to explain to him at first tolerances, problems, things that it just wouldn't be that way. And that was not important to him because he had read in the instructions where it said exactly 1.25 inches, and he didn't want to mess anything up or have his trailer go bad down the road because he hadn't followed their instructions. The ones that were actually a little bit of a deficit in this situation of things were the other machine shops, when they were just his initial, it had to be exact, and weren't talking to him long enough to find out what's really going on. Okay, that way I don't have to find the end point again. And back here to the key. Yeah, I wish the light on this lathe was working like it should. Okay, we're in the keyway. Not as smooth as I would like it, but it would be acceptable to the customer. And since part of what we try to do here is make a profit, if it's straight, if it works, we're probably not going to worry about trying to make it prettier. Actual functioning, in this case, a slight groove to the finish. And what I'm doing is feeling for chips with my hand here. I didn't feel like going to get solvent and really washing it all off, but I'm feeling for chips that will mess with our measuring and wiping them out. You can feel chips much smaller than what you'll get off from a rag or just normal situations. Something I keep stressing about when it comes to accurate things. Wipe it off with your hand because you can feel it. Okay, so what did we end up with? Oh, I set the 2 to the wrong side. I'm not going to reset it. But our 2, I set it 2 on the positive. I should have been 2 on this side to get the correct measurement.
Oh, now let's do it 4.
Okay, so it didn't take out as much in the end. Took out more at the first. I'm still going to go ahead and see what one more cut will do, but that didn't look that encouraging.
Why is that?
Taper.
Oh,
Yeah, I got taper in the cut.
why would that be?
Well, there's a couple reasons for that. One is that the tool may have worn a little bit as we went. And I see what might be a slight angle worn on the top of it. Sometimes you can have a slight wear and it's just wearing itself into where it's going to stay. Could also be that this machine, I have not done this exact work on this machine before, this machine may have an inaccuracy to it. The older machine I've used for this sort of stuff, and it runs dead true. Had Austin not put it here, I would have put it on the older, more worn machine that I knew was straight. But we started here, so we will continue on. And we will go over here, which should be 1/1000ths total from where we started. And we will see what happens. If we don't like it, we will then change to grinding, and unfortunately if we don't like that, then we will go to the other thing, which is changing to the other lathe too. Okay. Well, this is interesting. So that is a tool wear issue because it's not cutting at the front. It's just scraping the oil off. It's not cutting, which is about how much taper I was seeing.
Okay.
So that brings to mind another thought here too. I'm going to go ahead and temporarily stop the feed. You can stop your feed in a rotation. You let it clear out your cut, and then you can stop in the middle of something. It's not, if it was a finished cut, you wouldn't want to do that if you could avoid it. But what you don't want to do is not let it rotate and clear out before you stop it. If you stop it while it's still traveling through and maybe even taking a micro cut, that can damage your tool bit a little bit. But if you stop in a place, let it rotate a few revolutions, the tool will cut all that it's going to cut in that location before you shut the machine off. I want to try a different, little bit lower RPM. So, 180 seemed plenty slow, but you know, we're getting some wear on the tool. So, we will just go slower. You got places to go today, huh?
Yeah, I gotta leave about noon.
Ah, yeah. This was actually bid at 12 hours. So, you know, to a lot of people, God, why take all that time just to bore out a few thousandths? Well, they paid us extra to make sure that we can do it without going even a half a thousandths over. They want it right. They want it.
Yeah, you gave a really good explanation for why. How many old machines like that do they run up there?
This is just one like this. This is the machine that, well, as far as old machines, yeah, the ball mills, the sag mills, that stuff will be old too. Stuff we had at Red Dog Mine, our sag mills and our ball mills, I think our later ball mills were made in the 50s. First ones were out of the first one was out of the 40s. The sag mills were 40s, I think. They had brush motors. Motors had brushes on them, which is not that uncommon even in the 60s, 60s, even 70s, to be running brush motors, because you've got an exciter. You've got a field. Instead of running a squirrel cage for extra torque, they will run a wound rotor. And so what it's got, normally the way your three-phase motor works is you have a squirrel cage, they call it, in the middle of it, and the magnetism from the windings that's making it run induces a magnetism on the squirrel cage, which is actually wound also. There's actually a winding of just one coil loops of little wire, little conductors, not wire, they're bars, that are in there to conduct current and make magnetism. They self-induce magnetism from the magnetism in the stator that is given the power to make it run. But when you want more torque, you want to have that center rotor have a high magnetism to it to begin with. And so for it to have a higher magnetism, instead of just being induced, they have an actual winding of coils in there to make an electromagnet in the rotating part. So now the rotating part needs some way to get the electricity to it. Later machines, you can start it running with a reduced current or frequency drive, and you can get it turning. Once it's turning, you can do a brushless. So essentially you have a generator that's rotating around that provides the current for that center magnet so that you don't have brushes to wear out. But it's common because it's just so much simpler and less troubleshooting. You just have some big quality brushes and they sit there and run for years. So if we actually spend 12 hours on this, do you think we should put 12 hours of it up on YouTube? People are wanting me to do longer stuff and actually watch me work. So we put full 12 hours. We can do it in segments, you know?
Hour 1, hour 2.
Hour 2.5 to 3. So I'd set the 0 last time so I didn't have to look so close where the end of the cut was. Now the real answer on this would be to bore out 2/1000ths and then hone it. But to hone this, you'd have to make a filler for the keyway. So again, you got work for that too, because you can't hone across that big of a keyway. You can hone across small keyways if you use what they call keyway hones. And when we're talking about, well, I can talk about it now too. Anyway, it just has, instead of having 4 places for the stones, it has 8. So that there's 2 of them here that can help guide this one across the open place for the keyway. But that is a huge keyway. When you start talking jumping across that with a hone, I think you'd really have to build a special hone with a helix to it to make it work without, or at least the wipers could have a helix. The stones wouldn't necessarily, but you can have some wipers that are helical. But you can make a filler for it. You take some stud and bearing mount, lock your key in there, and then what we'd do is we'd bore the keyway right with this so that it was, even if we were boring it by itself part of the time. Keep cutting that so it's all nice and smooth. A little split in between wouldn't matter. Then you warm up your keyway and the Loctite comes loose and you pull out the piece and deburr it. But that's also a 6-inch diameter to hone, roughly 6-inch diameter. And since we don't have a honing machine, we just have hones that we run by hand. I really don't want to be honing a 6-inch if I don't need to. I have honed as big as a 12-inch by hand in here, but pick the easiest way or the least expensive way. The tool bit doesn't look any more worn, so it could be that am I hitting? It could be that that was just a matter of the initial wear in the tool. Sometimes I'll do a little bit of an initial wear and not, and it looks better now. Oh, we don't know. That takes measurement. That doesn't look. Yeah. Many moons ago, a young man was working for me. He had some holes he was making, and he was running reamers to final size the holes. And I said, this one here is off. I pointed at one of them and I said, this hole's wrong diameter. And I said, it's like 1.5 thousandths big or something. I told him a size. And I was dead on the size by guessing. And he actually, for a long time, in fact, I think he still, but he'll probably watch this and catch on. He had thought, because I said, my machinist eye. Well, my machinist eye, yes, does give me some idea of sizes looking at things because you're used to it. But the big thing was I looked at the surface finish. The surface finish of the reamer has a given size. You can look at the side of the hole, the surface finish, and you kind of learn how much is the reamer moving off center. And you do that by surface finish, plus the reamer has an original size to start with, so your guess can be pretty close without really guessing by looking at it. But he actually thought that my eye was trained enough that I could tell within 0.5 thousandth the size of the hole by just looking at it.